Hey YouTube, so in case you don't know, this is a Tangram Cube, and this is definitely one of the more unique non-WCA puzzles in my collection. The name comes from the Tangram, which is a Chinese puzzle with 7 pieces that fit into a square, and as you can tell on every side there are 7 pieces that fit into a square. So I'd say it's a pretty fitting name. Anyway, you don't care about that. What makes this puzzle so unique is that it actually turns on 5 axes. Now, the puzzle is a cube, and lots of cube puzzles turn on 6 axes. Picture a 3x3 or a 2x2 or a 7x7. They all have 6 centers, and you can turn around those faces. And maybe you'll see something like a Pyraminx which turns on 4 axes and has 4 faces, or a Megaminx which turns on 12 axes and has 12 faces. But if you're just familiar with WCA puzzles, you definitely won't find anything with 5 axes. And so when you first pick this puzzle up, it's awfully confusing and it almost feels like it turns totally randomly. But there is actually a really satisfying order to it once you understand how the puzzle works. So basically there are these 3 layers, the top and bottom layer are the same, and the middle layer is sort of its own thing, which honestly is very similar to how a 3x3 works. But instead of having 4 different ways to turn besides the top and bottom layer, like how on a 3x3 you have the front, right, left, and back, on this puzzle there are only 3 other ways to turn. So if you set the puzzle down in a standard white top, green front orientation, you'll see that you can turn the UR edge, which is the upper right edge. You can also turn the DF edge, which is the down front edge, and the BL edge, which is the back left edge. So those are the 3 ways you can turn besides the top and bottom, and now you can see that you can actually turn the top and bottom around the corners on UFL and DBR, which is the up front left and down back right corner. And so that together makes up 5 ways of turning. And this puzzle also doesn't shapeshift, which means that if you're turning the corner faces, there are 3 valid turns, and that if you're turning the edge faces, there are only 2 valid turns. You can turn them 180 degrees at a time. And so you can totally draw some parallels here where you can define some of these pieces as centers, edges, and corners. For example, these pieces with 2 colors on them are basically like middle layer edges on a 3x3. These larger pieces in the middle layer are like centers. The huge edges are also like a type of edges. The corners that you turn around are kind of like centers. And these tiny triangles are a lot like corners. I'll leave that up to you guys to sort of wrap your intuition around it. I think the best way to do this is to probably get a Tangram Cube for yourself and play around with it. But for now, I'm going to go into a basic solve just so you can sort of see the general process I use to solve it. This isn't a tutorial, but it might be kind of helpful if you're a really intuitive solver. But the point of this is for you to understand a little bit more about how the puzzle works. So you'll see that I start out by solving this middle layer, almost like a belt method. Then I move on to the top layer, and I solve the edges around the top layer center, which is on the corner of the cube. Then I do the same thing on the bottom layer. I solve the edges in relation to their center. Finally, you'll see that we're left with some triangles here, which I call corner pieces. These are solvable using some basic commutators that I derived, which basically move around 3 corner pieces at a time. Anyway, that's a solved Tangram Cube. So I didn't solve that very efficiently, but I was really curious about how a computer would be able to solve this. So let's talk about God's number. So briefly, God's number is the maximum number of moves that is ever required to solve a cube. So for the Rubik's Cube, the standard 3x3, God's number is 20. You never need more than 20 moves to solve any position of the cube. Now, of course, you could take more than 20 moves, but if you do it optimally, the way a computer would do it, you never need more than 20. So the Tangram Cube is a lot simpler. It has way fewer pieces, and so I figured God's number would be significantly smaller. Now, my estimate for God's number before I started this was around 14. That's just an estimate. I wanted to find out the answer. And so I went to everybody's best friend, KSolve Plus. For those who don't know, KSolve Plus is a general puzzle solving program, which might not sound that exciting, but it really is a super powerful thing. So the idea is that KSolve Plus isn't like Cube Explorer where you can only do 3x3s, or maybe like some other puzzle solvers that are specialized, like a Pyraminx solver or a 2x2 solver. KSolve is made for solving any puzzle you want. You just need to be able to define it. So all you need to do is define the pieces on the puzzle. So like for a 3x3, you would say there are 12 edges with 2 orientations each and 8 corners with 3 orientations each. And then you define what each move does to those pieces. So you might say for a 3x3 that a U move moves the up front left corner to the up back left position, and you need to do that for every piece that it affects. So I don't want to make this sound easy. This takes some time, and if you're new to the program, it will take even longer. It could take you a couple hours to wrap your mind around how it works, but it's super powerful once you really understand how to use it. And plot twist, I don't really understand how to use it. Ksolve Plus didn't end up working for me. Now, I don't want to bash the program at all. It's a really powerful thing, and I was actually able to define the tangram cube perfectly, and I was able to also get optimal solutions for it. But when it came to calculating God's number, which is something that Ksolve Plus is supposed to be able to do, I wasn't able to do it. I kept trying to run this line of code in the command line, and it just kept halting after 10 moves. It would get 10 moves deep into the puzzle after like a minute or so, maybe 2 minutes, and then it would just say, nope, I'm done. And I don't know why this is. It could be a problem with my computer, it could be a problem with Ksolve, it could be a problem with me. To this day, I have no idea. But I'm not leaving you guys unsatisfied with this question. I really wanted to find God's number for this puzzle. So in an attempt to resolve my Ksolve problems, I reached out to Lucas Garin, who is a very smart cuber who has done a lot of cool programming projects for the community. And he actually pointed me to something that I am just amazed by. It's called TW Search, and this thing is absolutely insane how powerful it is. So TW Search is basically a reprogrammed version of Ksolve that Lucas Garin and Thomas Rokicki made. And I'm not joking when I say this thing is powerful. I was facing this problem with Ksolve for a while, and TW Search solved the problem so fast that it didn't even feel like it was a problem. It trivialized what I was doing so much that I started to question if it was even worth making a video about it if it's that easy to do. But of course it is, because TW Search is amazing, and more people should know about it. So currently it more or less works with Ksolve definition files, so I just imported my tangram cube definition file into the directory that TW Search was in. Then I compiled everything, and I ran the God's number calculation. And Ksolve Plus took over a minute to get 10 moves in and give up. TW Search took about 15 seconds to calculate the entirety of the God's number tables. And I watched this happen, and I was just in shock. I didn't even get excited about what was happening because it happened so fast. And so the answer, after all this work, and then finding something amazing that did all the work for me, is 16. The tangram cube can never take more than 16 moves to solve. But the super cool thing about this is that TW Search also gives you the number of states that are n moves away from solved. And so the way to read the second line here, for example, is dist 1, count 7, total 8, which means that there are 7 positions that are 1 move away from being solved, and there are 8 total positions that have been searched so far. So that means there are 7 that are 1 move away and 1 that's 0 moves away. And so you might notice something cool as we scroll down a bit here. You'll see that it starts to get a lot more as the numbers go up, so we get to 42 million positions that are 12 moves away. And there are only 111 million positions total, so that's almost half of them that are actually 12 moves away. And significantly more than half that are 12 moves or less away from being solved. As you can see, there are 70 million. So after 12 moves, you'll see that the number of positions that require 13, 14, 15, 16 moves start to get a lot smaller. And the surprising thing is that there are only 4 positions out of 111 million that require 16 moves to solve. This is very small. 4 is a small number normally, but out of 100 million, it is an especially small number. And so I was curious, what are the 4 positions that require 16 moves to solve? And fortunately, TW Search actually spits out up to 5 of the positions that require God's number of moves to solve. And so these positions are called antipodes. And so I was able to plug the antipodes into TW Search as scrambles and actually get solutions for them. And when I undid the solution for one of them, I was shocked at what I saw. The farthest you can be from solved on this puzzle is this. This is the farthest from solved you can be. This is literally the closest to solved that you could be on this puzzle, and yet it's the farthest from solved that you could possibly be. Hey, future DG here. One thing I realized I forgot to clarify is that since there are 2 centers on this puzzle that can be twisted in 3 ways each, and 2 of those ways are not solved, the 4 positions that take 16 moves to solve are all 4 twists of these centers. So twisting one center clockwise, twisting one center counterclockwise, or doing either of those to the other center, those are the 4 positions that require 16 moves. Anyway, thought that was important. Back to the video. Twisting 2 centers is closer to solved than twisting 1 center. Being completely scrambled is closer to solved than twisting 1 center. I know that the super flip on 3x3 is 12 flipped edges, and that's 20 whole moves away from being solved, even though all the corners are solved already. But this just takes that to such an extreme. And honestly, I love the tangram cube so much more now that I found that out. So in case you can't tell from my excitement, I really love TW Search. And if anybody needs any help setting it up, feel free to leave a comment down below and maybe I can help you out. And definitely check the description too, because I'll probably be putting some frequently asked questions there. It definitely takes a while to learn and a while to set up, especially if you're new, but Lucas Garin did mention that he's hoping to have an online version up and running soon, which means you'll be able to do it without any of this sort of command line stuff. Definitely stay tuned for information on that, and if you're watching this in the future, check the description, because I'm going to update that with more resources as time goes on. Anyway, huge shout out to Lucas and Thomas, and to all the people who have put time into Ksolve, Ksolve Plus, and Ksolve Plus Plus over the years. These are really cool programs, and I feel like Lucas and Thomas are just taking it to the next level. Anyway, I really hope you enjoyed this video. Thanks for watching, and I'll see you on my next video.